Good morning, everybody, and welcome. First of all, to say a big thank you to the University of Cyprus for hosting us here today. It's a great pleasure to be here. So we've been working with the university for many years now, pretty much close to when it was founded, and it's always a huge pleasure to be here. So thank you very much. And we're delighted to be here today to talk about an exciting subject. My colleague David Lyford-Smith will be doing just that in a short time. But also here today, we want to introduce you also to our professional body, the ICAEW, or Institute of Chartered Accountants in England and Wales, which is an international professional body headquartered in the UK. Just to give you a little bit of background, we're delighted also that today we will have a few professional services firms who train the Chartered Accountant programme in Cyprus, and I'll just read them out in alphabetical order. So they will be BDO, Deloitte, EY, Grant Thornton, KPMG and PwC. And certainly these names mean a lot to the ICAEW because they were the founders of our professional body. They were the first presidents of our professional body. So we have a huge legacy and history in the professional services arena. Professional services arena has grown, and technology services now play a huge part in the services which are offered to businesses. So a little bit about the ICAEW. It's been around for some time. So it's founded in 1880, and it is a world leader in the accountancy, finance and business profession. I already mentioned that the first presidents of our body were the names that I'd mentioned before, the founders of the professional services firms that we have today. I mentioned that our headquarters are in London, but as an international body, we have an obligation to support our members wherever they are in the world. And so we have various offices throughout the world. And here in Europe, we're headquartered in Brussels. We have a presence here in Cyprus, and we look after Cyprus and Greece from here in Nicosia. A little bit about the market recognition of our finance and business qualification. We're proud to say that the major corporates continue to trust and employ chartered accountants, as do the world's leading brands too. And closer to home, here in Europe as well, we do see huge recognition for the ACA with regards to jobs in finance, accounting and business. So what is our strategy? Our strategy is to build a world of strong economies wherever we have a market presence, to work together with the national institutions to advance the accounting and finance profession, because we believe fervently that a strong accounting profession is part of a strong economic infrastructure leading to a successful economy. So areas such as transparency, reliability, accountability of financial information and financial stakeholders are really very important to us. Part of that also is financial education and financial literacy, and Cyprus has been a leader in this regard, offering the ACA for over 25 years now, the first country where we have been training outside the UK. So it is no accident that Cyprus is a successful business centre it is today. And we work with universities, we work with your university on a number of different levels, and of course with the national body here, SELC, Σύνδεσμος Εγκεκριμένων Λογιστών Κύπρου, on a number of various issues. So I'd now like to hand over to my colleague, David Lyford-Smith, who comes from ICAEW's IT Faculty. He is a chartered accountant and an expert in blockchain, but he will credentialise himself so much better. David, thank you.
Well, thank you very much, Christiana, and thank you everybody for having me here this afternoon, and thank you for joining me. As said, my name's David Lyford-Smith. I work out of the London office of ICAEW in our IT faculty. It's an unusual thing for an accounting body to have, you might think, a body that cares about IT. But since 1993, there has been a group at ICAEW under the title of the IT faculty, which has centered its work in researching and understanding the impact of technology on the profession. I joined the IT faculty around 3 years ago. I am a ACA qualified chartered accountant myself, so my background is in professional services. I was an auditor for some time. I worked in outsourcing for some time, and also as an Excel and spreadsheet expert for a while as well. But I joined this group, the IT faculty, around 3 years ago, and since then I've been very pleased to be a part of our research into what technology is doing with the profession and what the profession can do to prepare itself so that we as accountants are ready for the impact of technology. We can't just wait to see what happens and try to catch up after the fact. We take a position of trying to be ahead of the curve and trying to make sure that we are ready for the future. So the IT faculty has lots of different jobs. We do research on technology. We speak to our members and to businesses about what they're using technology for, what their concerns are for the future. And we also help to inform our qualification, so making sure that the syllabus includes aspects of technology that we think that the accountants of the future will need to know. And that's some of what I'm going to be talking about in the speech today. So there are 4 of us in the IT faculty. Here's me. I look after any aspects particularly to do with the profession aspect of accounting, so those members who are working in practice rather than in business, although I do touch on business as well. And in particular, I look at the digitalization of tax systems and how tax is becoming more automated and more tech-aware. I look after blockchain and cryptocurrency, which will be the main topic I'll be speaking about this afternoon. And I also help head up our Excel community, which is the group that we have that focuses all about how to use spreadsheets properly and safely, because it's such an essential part of the accounting job. I was formerly with BDO. I spent 6 years with them in a variety of roles, most latterly having been a full-time Excel and spreadsheet specialist. So accounting can take you into some interesting places. The ACA qualification can take you to some unusual paths. It's a little bit about my path. And what I'm going to talk to you about now is a bit about the future. So technology as a topic is something that has grown from being a niche interest or a specialist area to something that consumes the attention, I think, of all of our members, and something which is on the agenda of every professional services body, every company, and every accountant. It's become an incredibly important part of what we do. The ICAEW IT faculty approach to how we think about technology and how we do the research work that we do is outlined here. This, on the left here, I imagine you will not be able to read, but it's a publication called Providing Leadership in a Digital World. And this outlines the way that we think about technology and how we approach it. And our approach is to go out to businesses, understand what they are doing, what they want to be able to do with the technology, and always to reflect on the core aims of the accountancy profession. We are not interested in thinking about, can we just do the same things we did for the last 20 years, but maybe a little faster? We want to think about what really fundamentally do we as accountants want to do. We want to provide trustworthiness to the world of business. We want to provide good advice to businesses. We want to be able to help serve the public interest by providing assurance over and trustworthiness in the numbers that people see in accounts. And we want to be able to achieve those goals, and we're open to using technology to transform the way that we do that. So we are always trying to position ourselves for the future. And as a result of that work, we have identified 4 key technology trends, and I'm going to talk to you a little bit about each of those today, but I'm going to be focusing on one in particular. But these are the 4. We've used the acronym ABCD to make them easy to remember, but that's nice and convenient. So these are the 4 top trends that I'm going to be talking to you about this afternoon. Artificial intelligence, as well as related topics like automation and machine learning. The main topic for this afternoon, which is blockchain, and the related topic of cryptocurrencies like Bitcoin, cybersecurity, and finally data and related topics, big data and data analytics. So I'm going to talk a little bit about the A, C, and D topics to start us off, and I'm then going to spend the majority of the session going a little bit deeper into this new and interesting area of blockchain and related cryptocurrency questions as well. So I want to start with some pictures of 4 people who are particularly important to the history of one of these topics. It's not that likely that you recognize any of them, except maybe the second guy. He's a little bit better known. Does anyone know who any of these 4 folks are? Guy in the white shirt, I think? So the second guy is Garry Kasparov. He's a grandmaster chess player and since then politician. But he's famous because he was the world #1 player of chess throughout a lot of the 1990s. So all of these people have an interesting history with playing games against AI. So the first guy is called Marion Tinsley. He was a mathematics professor from the United States, and he was famous for playing the game checkers, sometimes called drafts. It's a pretty simple game. Most people get to the point where they just draw against opponents, but Marion Tinsley was a little bit better than that. He was a professional player for more than 50 years, and in those 50 years, he lost 5 times to human beings. Just 1 game per decade did he lose to another person. So pretty good. The best checkers player ever. In the 1990s, he played a match against an AI called Chinook, and he lost 2 games in that 1 match to Chinook, and beat it 4-2, because he was really, really good. He was the last human to be able to defeat Chinook. Chinook, in 1992, solved checkers. It became perfect. It can no longer be beaten at all, no matter how you play. So he was the last person to be successful against playing a very early, very simple AI. And a little bit later in the 1990s, in 1997, Garry Kasparov, in a very high-profile chess match against IBM's Deep Blue supercomputer, was defeated playing chess. Now, chess is a lot more complicated than checkers. It's got a lot more going on. And the IBM supercomputer that was built to play against Kasparov worked a lot in the way that old AI systems used to work, which is that it had to be taught explicit rules. So the creators of it created a system that was given a huge database of different chess games and a lot of rules to assess whether a particular board state was a good one or a bad one, and a lot of rules for how to play in different circumstances. And it was given a massive database of information, and with this it was able to analyze games, look several moves ahead, look dozens of moves ahead, and figure out whether the game looked better or worse, and make decisions as a result. And that was enough to defeat the best chess player. And since the 1990s, human chess players have never been able to beat the best chess computers. But that approach to doing AI was quite limited because you had to know the rules and you had to be able to spell them out in a very explicit way. And it meant that Deep Blue, once it was finished beating Garry Kasparov, just went into a museum because it could play chess, and that was it. It was a very good technique for playing chess, but not for doing anything else. So we go a little bit later to the 2000s. The third person on this slide is Ken Jennings. He was a contestant on the American quiz show Jeopardy! One of the things in Jeopardy! Is if that you win, you get to come back the next night to play again. Ken Jennings was on Jeopardy! For about 4 months. He beat everyone for a very long time because his trivia knowledge was incredibly good and his speed was incredibly good. He could beat other contestants to the buzzer time and time again. He was like a human Google, although actually this was in the early 2000s, and so he was probably better than Google. And he makes his living now writing trivia books and doing talks. So in the 2000s, they set up a game with him and another Jeopardy! Champion against IBM's Watson AI. And this was not an AI that was connected to the internet. It had an offline database of information, but it had to understand the questions, the same as Jennings, press a electronic buzzer, the same as Jennings, and be able to answer in the right format. And it had to do that without access to the internet. You can't write rules for that. So the way that that AI worked was a completely new way of doing things, and it was based on this idea of machine learning. The idea that if you can expose an AI to a lot of practice data, a lot of questions and answers that it can try at and try at and try at, and you make slight variations to the program, and you chuck away the stuff that doesn't work, and you keep the stuff that does work, over time it gets better and better at the task. And this machine learning approach is actually very similar to the way that the human brain learns, and the way that we acquire information and knowledge not through learning a set of rules, but by learning associations. And it was much more powerful, and it was able to defeat Ken Jennings. And that brings us to the last gentleman, that's Lee Sedol. He's a Korean Go player. You might have heard just a couple of years ago that he was defeated by a AI called Alphago, which is owned by Google, at Go. Now, Go is a lot more complicated than chess. How much more complicated? Well, the estimate of how many different chess games there are is about 10 to the 130 to 170, depending on who you ask. The estimate for different Go games is 10 to the 360. So it's overwhelmingly more complicated. And it was thought that we were nowhere near being able to make a computer that could beat a human player at Go, and then we did it just a couple years ago. And that again was by using the more modern way of doing automation and AI with machine learning. This was not taught how to play Go, it was just created at random, and then it played millions and billions of games against slight different versions of itself, and the best versions got to stick around, and it got better and better and better. And the important thing is, unlike Deep Blue, AlphaGo doesn't just play Go. They taught it to play chess, they've taught it to analyze medical data, business data, map data, anything at all. It's an engine for learning, and it's getting better all the time. So artificial intelligence and automation and machine learning are inevitably going to be turned towards IFRS, towards auditing standards, towards accounting data, and they're going to get really good at it really quickly. Now, the work that we have done on artificial intelligence, this is a report called Artificial Intelligence and the Future of Accountancy, which we released last year. You can read it if you want. It's available for free at ICAEW.com/AI or /artificial intelligence, either one works. And what we said in this paper is that artificial intelligence and automation are coming to every field. This is going to be just as much as a shake-up as when robots started building cars instead of people. We're going to be looking at automation taking over the kind of more white-collar jobs and not just the blue-collar ones. And it's something that we have to think about, but it's also, all the research shows that the best uses of AI, the most successful uses, combine AI with humans. And it's about AI and humans working together. So the humans are good at spotting things that don't make sense, at interacting with other humans, at setting the business expectations and communicating and providing that judgment. And AI is good at doing relatively simple things very quickly. So that's the first of my ABCD topics, a little bit about AI and artificial intelligence. So the next topic I'm going to talk about, and it's going to be very brief, is cyber risk. In the past, it would be the case that on the board of a company, perhaps the IT director would talk a little bit about their cybersecurity, but it was not a significant concern. It was, again, seen as something that was quite nerdy and specific. But now, when we talk to businesses, they say that cyber risk is right at the top of their list of business risks. They are no longer thinking, oh, well, maybe we will lose some data, but they are thinking about, well, we are going to. At some point, eventually, someone will break in somewhere. How can we make sure they get as little as possible, we notice it as soon as possible, and we deal with it as well as possible? So it's more about how to react to risks than trying to make them impossible, because you can't make it impossible. We're also seeing that smaller companies might, in the past, have thought, well, we're maybe a small company or a small practice, we're not that appealing to a hacker, nobody would be interested in us. But now what we're seeing is that there are often attacks on large businesses which are carried out by attacking smaller businesses who are their suppliers or their advisors, or that get acquired. So, for example, a few years ago, there was an attack on TalkTalk, a mobile and communications provider, and the attack was done because they had recently acquired another smaller company, and the smaller company's computers had already been compromised by a hacker, and they connected them to the big company's computer network without properly checking and detecting this, and they were from there able to infiltrate the network of the larger company. And likewise, we've seen other cases where suppliers or customers who have access to large companies' invoicing systems or other systems have been able to use that to get in by breaking the lower security of a smaller company and then attacking the larger one. So cybersecurity is an increasing risk, and it's something that we are seeing moving up the agenda. We have several publications on this, particularly on the right here. This is 10 Steps to Cybersecurity for Smaller Firms, which is talking about what all of us, when we are working in the business world, need to know about cybersecurity, because we are in a position of trust and how somebody might try to trick us. So this is available at ICAEW.com/cyber. Now, the fourth area is that of data analytics, of so-called big data. We're living in a world where more information is generated and passed between machines than has ever been available to us before. But I think we all know that. We all know that, there is more data coming through Google and Facebook and so on than at any point in the past, through Amazon and all these other companies. What I think is easy not to realize is just how big of a difference it is to the past. So if you were creating a museum of human data and you wanted to store all the data that human beings have ever made, you have got room with a museum with two wings, so you put half the data in one wing and half the data in the other wing. One wing of your museum is 200,000 BC until 2016, and the other wing, with the other half of the data that humans have ever made, is 2017 to 2018. So pretty scary increase in the speed at which we make information. Now, that information is mostly what's called dark data. It's something that maybe a company has, but they don't know that they have, and they don't really understand what they might be able to do with it. And the other thing about it is that it's data that's unstructured or not well looked after or not properly taken care of. And I think as in the future, what accountants will be doing is helping to advise on how is this data being collected? How is it treated? How are we keeping it secure? How are we making sure that it's ethically handled and that what we use it for is proper and ethical as well as legal? Because there are lots of cases out there of companies doing things with their data which are within the law, but which are still not ethical, and that they get in trouble for when people find out about it, because it's not what people would have expected to be done with their data. So I think as accountants we'll become stewards of data and caretakers of the data of the future. So once again, we have a hub site for this with a few different publications. That's ICAEW.com/bigdata. The central publication that you see there is Big Data in Chinese Businesses, which is a study that we did alongside the Shanghai National Accounting Institute and a big data analytics company called INSPIR, looking at how the incredibly large data sets available to Chinese businesses is being used today. And going back to my earlier analogy, if you don't know how to play Go, that's a board of a game of Go on the cover there. So that's what it looks like. So the main topic that I'm going to be talking about this afternoon is blockchain, and a little bit about cryptocurrencies such as Bitcoin as well. So blockchain is an interesting invention, and I'm going to be talking about it from my perspective as an accountant and how I think about it. And I'm also going to be talking a little bit about this image. So on the cover of the report that we wrote on this subject, released last year, which is called Blockchain and the Future of Accountancy, this is the picture that we have on the front, this dominoes game. Now, you might have noticed from my AI example that I quite like games, but that's not why we've got this picture. It's because it's actually really interesting to think about this in relation to how blockchain works. But I'll come back to that later on, but just want you to think about that image of a game of dominoes. So what is blockchain, and why did somebody invent it? Well, blockchain is an attempt at solving a very old problem. And I'm going to talk a little bit about that problem and about some old solutions to it that we've been using as humans for thousands of years, and then talk to you about blockchain and how it's different from those. So the problem is this: we need to do business with one another. We need to interact with each other, but we've all got our own records. We all have our own idea of what's happening, and our records are sometimes different. And this is a very old problem. A trader going from one place to another trying to make sure that what they think is the case matches with other people, that the prices agree, that their history of who owes money to whom are the same. So we are all wanting to keep our records the same. We want to be able to do business with confidence, and we need a way of doing this. And there are three very old solutions that have all been in use for thousands of years. Number one, each person keeps their own records. So, for example, if we're doing invoicing between companies, for the most part, how that happens is I keep my sales ledger, someone else keeps their purchases ledger. We're doing our own records, and we talk to each other whenever we're making any differences to try and figure out the differences. Very, very old solution, before written history. A newer solution, in that it's maybe only 4,000 or 5,000 years old, is that we can apply to use a central gatekeeper, some sort of person who is going to be in charge of keeping the records and keeping them all the same and keeping them correct. So, for example, a bank. We keep track of how much money everybody has because we trust that a bank will keep those numbers up to date for us. Or we might appoint a government or a lawyer or an accountant, and in the past often a church or a cleric would do it. So this is another very old solution. Also another very old solution, but only a few thousand years old, so much newer than the other two, is using what a technologist would call tokenization, using an object to represent the debt. Of course, we just think of this as cash. It's a very familiar concept, but it was a very clever invention to use coins and to use cash to represent the transaction. And then we know what the records are because we can just see the object. So these are all old solutions to this problem, and they all have problems too. If we are all going to keep our own records, well, we have to worry about what happens when the records disagree. We have to spend effort arguing with other people to solve the disagreement. And we know when we want to make a decision, our records alone, it's not perfect. We don't know that those records are right. So we lose a little confidence, we lose a little bit of certainty when we want to act on those records. The second one, using a central gatekeeper, using a trusted authority to run the ledger for us. Well, number one, is there a trusted authority that will do that for us? And it has to be not just somebody that I trust, but somebody that everybody trusts. So we have to find somebody trustworthy to do the work. Secondly, they aren't going to do that for free. They're going to want a cut of the business to run the ledger for us. And thirdly, if their internet server goes offline, then we can't do business anymore because we need them to be there. So we have to find somebody trustworthy that we can afford and that is available all the time so that we can do our business. The third one, tokenization or cash, we have to worry about whether the token is real, whether it has been made fake, and whether we have to worry about forgery. And we also, in the internet age, have another problem. Tokenization in the past generally relies on physical objects. And physical objects have this handy property that if I hand this from me to someone else, it transfers from person to person. And in the internet age, that's much more difficult. This 10-euro note is a perfectly easy way of transferring value from me to you. But once I've gone back to London, a photograph of the 10-euro note that I send you on an email, it doesn't really work the same way. So this was the problem that people wanted to solve. So in the early 1990s, when the internet really took off and when the World Wide Web was invented, people said, well, what I want is something that's like cash. It's easy, it's straightforward, I can transfer value from me to somebody else, and it's easy to do. But it was really difficult to make that work. So people tried for many, many years to come up with an idea of doing internet currency, but they didn't want to use a bank, they wanted it to be like cash. I don't need to tell my bank or wait, I can just give the money from me to you. And so it took a long time before somebody found a solution that was safe enough and that would really work. And that's what blockchain is. It's a fourth solution to the very old problem of keeping everybody's records the same. Just like the other three, it has some advantages and some disadvantages. So I'll quickly go through those. Its main feature is that we all get to have a record, but the records will definitely be the same. that there is no controller, there's no one who is sitting in the middle, who is running everything, and we managed to do that without any doubt over where the records come from. I am, as I said before, an accountant. I think of things in accounting terms, and to me, I think of blockchain as universal entry bookkeeping, of the ability to make an entry in one place and then have it spread everywhere so that all records are the same and we know what's happened in the past. So in the paper, Blockchain and the Future of Accountancy, identify 3 P words, which are the 3 key features of blockchain. And I'm going to talk to you a little bit about each of these to give you an understanding of what makes blockchain work and why it's different to other solutions. I'm not going to go into tiny technical detail about exactly how it works, because whilst it's interesting, there's other ways you can go and look things up on YouTube if you want to know lots of specifics about all the cryptographic technology that makes it work. But I'm going to talk more about the features that makes it interesting instead. So the first of these features is propagation. So propagation, or spreading out, is this idea that when we make a change to our record, that change is then replicated and it spreads to everyone else's records so that we end up all agreeing on what's happened. So we know that when I give money from one person to another, that transfer of value happens and we can verify that the person does in fact have the money. And this happens, again, just to emphasize, without a central gatekeeper. We are not waiting for approval from the bank or from a central person. We can just do it between me and you, and it will work, but it will all end up the same. So that's the idea of propagation. And the second feature, after propagation, is a consequence of it, and it's permanence. When we are making new transactions on our blockchain system, we do that in a way that creates a permanent and unchanging record. And that's because we all have a record. Everyone in the room gets to have a copy of the ledger, and I can fiddle with my one, but I can't change your one. I can only add to it. I can't remove things. And this actually links to the structure of blockchain, how it actually works in practice. So I'm going to talk a little bit about that. So the name is a bit of a clue. It's a chain made out of blocks. What do we mean by that? Well, when we're making a new entry, a new transaction, we don't post them one at a time, but instead we wait and we gather together a few transactions and post them all together as a block. Now that block doesn't just have the transactions, it also has a security feature, which is a little signature which identifies and summarizes what happened in the previous block. So the signature lets us confirm that the previous block, that's in the right place, it matches the previous block. And well, of course, the previous block also has a signature that links to the block before that. And that block has a little signature that links to the block before that. And that's why we use this analogy of a chain, that each link is connected to the previous, and that provides us some security. So we can make new entries, but we can't delete or change old ones. And now the third feature I've chosen this vending machine image for, and this is, after propagation and permanence, we have programmability. The fact that we can program a blockchain not just to list old transactions, but also to update and include new ones. And the way that we do that is often called a smart contract, essentially a contract that's written with software that says, when this thing happens, make that transaction. So for example, maybe I'm an insurance company, I could create an insurance smart contract that says, monitor the weather in my island property that I'm insuring. If the weather reports an extreme weather event, a typhoon or a hurricane or something, then automatically some relief funds are released and paid across to the insured party. And that's done automatically. So that's the idea of creating a smart contract. And that's a pretty simple smart contract, and people have created all sorts of very complicated ones, but they're not fundamentally dissimilar to a vending machine. With a vending machine, you have an electronic and a mechanical smart contract that lets you purchase something on agreed terms from a vendor who isn't there when you buy it. So it's a very simple smart contract. The problem with vending machines, I think we all know, is sometimes they eat your money or don't give you the chocolate you want. And that is something that you don't have to worry about in the world of software, because you can read the code in advance and you know exactly how it's going to work, and you can test it before you sign up. So that's the three key features: propagation, permanence, programmability. And that loops me a little bit back to the report. So this is Blockchain and the Future of Accountancy. If you would like to read it, it's available for free at icaew.com/blockchain. And I want to talk about this image again. So the image that we see here is this of a game of dominoes. And what you'll notice at the bottom here, the ICAEW logo is about to place the 2-5 domino right here next to the previous one. And the number 2 here is not really a surprise to us, because the previous block had a 2 in it, and in order for it to be legal, this new domino has to start with a 2. That's how dominoes works. But that structure of matching the previous block with the start of the new one is exactly the structure that blockchain uses. It's that same way of connecting a chain together with a matching number. So what this means after we've been playing the game for a little while is our transactions, our dominoes, become permanent. Let me show you what I mean. This domino here, 4-5, has a matching 5 before it and a matching 4 after it. It's now the only thing that could possibly work in that chain. Nothing else could be there. I can't change that 4-5 domino to anything else. It's locked in place. It's become permanent. And that's exactly how blockchain works. Although dominoes only has 6 different transactions. So it's pretty simple. And blockchain has many, many more. So the technical details are a lot more complicated, but the overall structure of why when it's permanent is exactly the same. So that's a little bit about what blockchain is and the key features of it. So now I'm going to talk to you about a few cases where people are using blockchain out in the real world. And this is the bit where I talk a little bit about Bitcoin and cryptocurrencies more generally. So blockchain was invented because somebody wanted to create an online cash system. And I'm emphasizing cash rather than currency. You could make a currency quite easily. You could just invent one, but you'd end up having to use PayPal or a bank to transfer it around, assuming you could get them to agree. What they wanted to make was something like cash that you can just hand over from one person to another, as a computer scientist would say, peer-to-peer, without any rules or interference, just easy transfer of value. So what happened was that in late 2008, a person using the name Satoshi Nakamoto posted a white paper describing their idea. We don't know who that person is, but they described this detailed system, which we now call blockchain, that would keep track of the new currency that they'd invented, and that was called Bitcoin. Now, Bitcoin, and the way that Bitcoin works and that most cryptocurrencies work, and I say most because there's a lot of different ones that are all a little different, has some interesting decisions about how it works that are not things you have to do with blockchain, so you could do it differently. But to talk about how Bitcoin works, firstly, Bitcoin is open but pseudonymous. So what does this mean? So it's open, meaning that the transactions are readable by anyone. You could go onto the internet right now and just look at the live feed of new transactions being added to Bitcoin and see person A sends X Bitcoin to person B. That's available to anybody. However, you don't use your real name or any kind of identifier in Bitcoin. You use what's called a wallet. It's basically a bank account for most extents and purposes, but there's no bank. It's just a number. And that number that represents you doesn't have to have any tie to you. There is no anti-money laundering check. There's no know your client check. You can just go on the internet and make one, or make 1,000 of them, as many as you want. So we have full visibility of the transactions, but only with using these pseudonyms. That means we don't necessarily know who the real person is that's behind that account. So what that means is if a particular account says, I'd like to pay you 10 Bitcoin, it's very easy to check that they have 10 Bitcoin because we can look at all the past transactions and see them receiving Bitcoin and not spending it, but we don't necessarily know who that person is. and vice versa if we're sending someone some money. It's very decentralized. There's almost no central control. Even the 5 people who have the rights to try and make updates to the source code can't force people to take the updates. They have to convince the majority of Bitcoin users that the update is worth doing before they get to roll it out. And that means that it has got some governance issues. If they've got a problem, if they discover a security fault, or they want to try and change things up a little bit to make it more easy to use or more secure or whatever they want to do, that's a difficult thing to do because they have to convince people and it takes a lot of time. So Bitcoin, and this is generally the case for the other cryptocurrencies, but there are around 2,000 others, so I can't give you one answer that's true for every cryptocurrency out there, but that's generally the shape that they are in. Now, they're an interesting way of transferring value from person to person. They're not going to be what I focus on because I think blockchain as a technology to support doing business is more interesting than just cryptocurrency. So I'll talk to you about a couple of other examples. So first of all, land registry, the keeping of a record of who owns which parts of real estate. So I was giving a version of this talk a few weeks ago in Dubai. And in Dubai, the Dubai Land Authority has now started to keep some of the records of land transactions, purchases and sales of real estate on a blockchain system. Blockchain has this wonderful quality of being highly secure and provably secure, and that means if you're worried about having somebody tamper with the records, it's a really nice thing to know that it's on a system where people can't change those records. So it helps to crack down on the corruption, and it helps to keep everybody's records up to date. And now, cryptocurrencies currently, as you may well know, are quite expensive to run. They're fairly inefficient. So they're not going to be able to compete with something like Visa as a way of making online payments in terms of the cost and speed. Not yet. They're working on it, but not yet. But it's already at a level that's better than most land registry systems. So it's a good way of replacing that sometimes old and creaky systems with something that's a bit faster and cheaper, but also adds that really strong security. So I don't have to worry, well, what if a civil servant decides that he likes my apartment and changes the records to say that it's theirs instead of mine? They can't do that. Nobody has those special rights. So that's an area where I think blockchain is a relatively easy win. Still a lot of work to do to make that happen, but where it's an improvement. Now, my third and final example is about shipping. So, of course, very relevant here in Cyprus, but shipping is something that's incredibly complicated and also fairly low-tech by the standards of modern business administration. And I say that because a lot of shipping still relies on paper records. And the reason why is that there are a huge number of different parties who are involved in shipping. So there was a study done that said that a typical container of flowers, which went from the grower in Kenya to the port of Rotterdam in the Netherlands, to get there, it had to pass through 30 different companies and organizations and over 100 different transactions. So it takes a lot of different people and a lot of work for shipping to work. And all those people have their own sets of books, and there's an awful lot of money spent on reconciling differences between them and disagreeing about who received and sent exactly what and where, and it's just quite ineffective. So the idea is if you can create a system that means that all of those different people that are involved in shipping can all agree on their numbers, it would be cheaper and better for everyone. Now the problem is that all those different people don't like each other and don't agree with each other about how things should be done. So this is not going to be an overnight solution where everybody goes, oh, well, that's clearly better than what we're doing now, let's go do it, and next day done. It's going to take a lot of time and effort negotiating between all the different port authorities, shipping companies, insurance companies, rail freight companies, container manufacturers, and suppliers and customers, all of whom are going to have to move on to that system. So it's a significant effort to be able to get there. But if that system can be designed, if you can get the majority of people involved, it will save everybody money in the long run. So I think for business, something like shipping is a really good example, but really any supply chain situation, anything like that could benefit from having this, because blockchain is a solution that can't work for one person alone. It's a consortium solution, it's a group solution. It's something that makes things better for a lot of people at once. If it's just me, I can just keep my details in my database, in my system, in my Excel spreadsheet if I really want to, and it will be fine. I only need to worry if I have lots of other people that I need to stay on track with. So that's a little bit about some examples of where you might see blockchain coming up in the future. Now, the original Bitcoin white paper was published almost 10 years ago now, in late 2008, and Bitcoin itself, the first blockchain, started in early 2009. So whilst we talk about blockchain as a new technology, it's not that new. But what has changed in the last few years is that the attention and the research and the effort put into making blockchain a technology that we can use in business has drastically increased. And the attention that these systems are getting is really kicking off, and some of the really big players are starting to really pay attention. So I think that blockchain as a solution has got a really interesting place. I think as future accountants, we have to think about what blockchain does help us with and what it doesn't, and I've got a little bit to say on that perhaps later. And we have to think about it as a technology. It's a technology that provides trust. It's designed so that instead of having to say, I trust the people I'm doing business with, or I trust the bank to keep the records correct, I can say, I trust the system which I use to make records, so it doesn't matter if I don't trust the people I'm doing business with. I'm safe. I can trust the system instead. And as accountants, we are often in the business of providing trust, of providing assurance. And so it is something that I think is very relevant to us and something we have to think about for the future. So I would like at that point to turn to you to ask questions, whether that's about blockchain, cryptocurrencies, or the other ABCD topics, so artificial intelligence, cybersecurity, and data that I mentioned earlier. Thanks very much for your attention. Let's get some questions in.
So he's asking about money in the middle attacks and blockchain or cryptocurrencies. Money in the middle attacks, yeah.
Man in the middle attacks. So what we've seen so far in terms of security is that nobody has been able to make a successful attack on the actual records on blockchain, but that doesn't mean that nobody has managed to trick somebody into sending money to somebody that they shouldn't at some level in the system. It has the same kinds of risks of tricking a human that any system has. The difference is that if I accidentally or through fraud send money to the wrong person via my bank can take the money back and give it back to me, and in blockchain system, my money's gone, because it's very secure and it's permanent, so we don't have any recourse for getting things back. So what we are seeing, therefore, is that whilst the underlying level of the system in blockchain is really, really secure, we still have the same concerns about all sorts of different attacks that can trick the human that's using the system as much as anything else. So it isn't a perfectly secure system. It isn't invulnerable to those sorts of attacks, unfortunately, any more than any other thing is.
Congratulations for your excellent, very clear presentation. Now, one approach to the innovation process is to combine elements from the four basic types of innovation process, product process, organization, and marketing. And through this combination, we may have thousands, millions of implementations. But we use constraints and criteria to narrow the search space. Because at the end of the day, we are looking for one innovation. four basic types of innovation have to fit together, like in domino. Okay, otherwise, we will not have effective innovation. Now, my question is more general. From your experience, has blockchain been applied in the innovation process in any way?
So just in case you couldn't hear in the rest of the room, the question is about whether blockchain has been applied in the innovation process and in businesses. So it's definitely true to say that most applications of blockchain at the moment come attached to words like lab or proof of concept or project. You know, it's still very much a research and experimentation area with a lot of ideas and not that much that's being done just as business as usual, ordinary, normal stuff. There are some exceptions. There are some areas where blockchain is just being used on a day-to-day basis, but it's mostly about, at the moment, you know, in terms of the framework you were talking about, it's a process innovation. It's about a different way of keeping records that offers some advantages and some disadvantages over the other options we have, and it's still something that people are figuring out exactly where to apply this. The other problem, of course, is that blockchain is getting a lot of hype right now. Like, there's no point about beating around the bush. It is something that's getting a huge amount of attention and that people are very excited about, and sometimes people are a bit over-excited about. The famous example is the Long Island iced tea company, company that make powdered drinks in Long Island and sell to bars. They changed their name to the Long Island Blockchain Company, and their market value went quintupled. They didn't make a blockchain, they just changed the name to have blockchain in the name, and the shares quintupled in value. It's a great marketing innovation, yes. Their shares then went down again very quickly when people realized, but if you were a shareholder for those few hours, it was a great time to be alive. So yes, there's absolutely a lot of excitement. Yes, most of the things are still proving that they can work. There's still a lot of kinks to be ironed out depending on what people want to do with it. But I hope that covers the general gist of it. No problem. A question here.
Sorry that even I came a little bit late. I would like to ask you, operation of blockchain and digital currency are based on internet and electricity. If we have a problem in these two factors, what can be happening?
So the question there was, you know, blockchain and cryptocurrencies are internet and electricity-based things. If those things go down, what's our problem? So one of the things that's nice about how blockchain is designed to work is that it doesn't have a single point of failure. If the internet of my bank goes down, I can't do any banking until they're back. If the internet means that a bunch of the people in my blockchain network are unable to access the internet, everyone else can just keep doing business without them, and then when their internet is fixed, they can catch up and keep on doing business as well. So it's designed to be a more distributed system that has more ability to cope with some particular node falling down than a more centralized system, which needs the center to stay up and stay available.
If in the future we will be more involved in blockchain and digital currency, we will not have any alternative transition from previous methods to apply.
So yes, it's true that, you know, if all of your system is relying on being able to do business on that online system, you are more reliant on it. But I mean, I don't think we are kidding ourselves in saying that we are not reliant on internet and electricity for business today. I mean, it's not that we have replacements of those systems that were on a large scale. I mean, there are some cases of people trying to, you know, who have fallen victim to cyber attack, trying to go to paper record systems to cover the gaps, but it's realistically not possible for most large businesses today to be able to keep up without the use of technology. So yes, I think we'd be reliant on electronic systems, but I don't think that's any different to any other part of modern business. Yes?
I would like to ask two questions. The first one is maybe there is a need for a central authority because the businesses have to pay taxes. So maybe with blockchain there is no control and they can hide dirty money. And additionally, the proof of work is a procedure that needs a lot of computational power. So maybe there are concerns about the environment and the pollution. And the second question is, from your experience, the machine learning approach?
Okay, so I'll take your questions one at a time. So first of all, centralization. So it definitely depends on what you want your blockchain to do. To be a cryptocurrency, for the most part, the goal is to be as decentralized as possible. And that means that, yes, there are significant costs in the proof of work or whatever algorithm they're using. And that's because there's no other form of security. You don't have any idea who anyone else is. You don't trust anyone else involved. You don't know if they're a genuine person or not. So to replace that, you have to do a lot of work to secure the transactions to make sure that everything is safe. And yes, that takes a lot of electricity. If you're building a business blockchain, so let's say, for example, overnight bank lending, different banks want to use a blockchain so that they can track balances between them and a half a dozen other banks, that would be more centralized. You aren't going to allow anybody into that circle. You're only going to allow the people who are running those large banks. You know those people a bit better as well, so you don't need to make the security quite so high, and so you can make the system, you can use a looser and less energy-intensive system. So blockchain as a system is an awful lot of different levers, and usually if you want to make one thing better, something else gets worse somewhere else. So it's about finding the right balance for the specific business application that the people want to pick. So yes, most blockchains are probably going to be more centralized than something like Bitcoin, and therefore will have different structures. Bitcoin is designed to be Bitcoin, and you don't have to, not all the blockchains have to work in that way. The second thing was about talking about machine learning and artificial intelligence. Now, realistically, there is not a generally agreed line where we say, okay, well, this side is machine learning and this side is artificial intelligence. And indeed, the same spectrum also includes automation, robotic process automation, intelligent business systems. There's lots of different terms out here, and they all sort of blur into each other and overlap. So I don't think you can say that there's a distinct line. It's definitely the case that machine learning-driven approaches, many of which do touch into the realm of artificial intelligence, depending on who you ask, are used all the time. I mean, every Google search you do is powered by one. Every YouTube recommended video is given to you by an AI of some kind. These are things which businesses are all really interested in, but a lot of them more in using those tools than making them themselves. Very large businesses and the large professional services companies, yes, are looking at, okay, well, how can we use machine learning to solve our particular problems? And others are looking at using them as services that purchased from an advisory company to help them out. So there isn't a clear answer to that one, I'm afraid, because it's not a term that, you know, we can draw a line and say, well, this is one and this is the other. Much the same as actual intelligence. We don't really have a consistent definition for that either. So, yes.
Yeah, I'm just wondering how the ICAEW is responding to the need for the qualified accountants to be aware of these new technologies, whether the curriculum is adapting, whether it should adapt.
Well, thank you for the question. The question is about how we're keeping our curriculum and our members and our students up to date. Well, one of my other jobs is speaking with the people that design the ACA syllabus about technology content in the ACA syllabus. So I can tell you that all of the topics that I'm speaking about here, the ABCD topics, are already in the ACA syllabus to a different extent for each. Two of our examinations from this year are now actually have technology in the title of the paper, so it's not just a kind of element of it, but it's a central pillar of the business strategy exams, that we consider technology as a part of that. But we're also looking in a larger sense as well, because it's not the case that we can say, well, if we train people when they're doing their qualification on the latest technology at that time, then they are good for a 40-year career. That's not the world we live in anymore. So the other thing we're looking at is a difference in how we think about career-long learning, and not just kind of CPD hours, but actually completely new approaches to trying to think about how we can help people to stay up to date and re-skill and relearn throughout their careers. So we're thinking about how we can change ourselves to adapt to that system. And the other thing that we're seeing is that it's not the case anymore that we have a very defined silo where accountants do accounting stuff and computer scientists do computer science stuff and lawyers do law stuff, and they're all kind of in their own buckets. Everybody is starting to learn a little bit of everything. And so one of the things, as well as teaching accountants some of the fundamentals of technology, we're also looking at reaching out to people who are doing technology qualifications and teaching them the fundamentals of accounting and of business so that they can understand the data that they are working with in their work, and that they can not just see it as another database, but really think about what it means. So a few different elements of that. So.
Just a small announcement before the next question. For the students especially, I'm switching Greek. Υπάρχουν τραπέζια από την ICAEWs Alphago, άμα φύγετε πριν το τέλος, οπότε μπορείτε να μιλήσετε με αυτούς περισσότερο για άλλα θέματα. Sorry for the interruption.
Yes, I'm sure what he said. Yes.
My question is, as an accountant, in particular, should you check any blockchain accounts? And if not, is there any indication you can see that anyone can be money laundering through blockchain?
So auditing of blockchain and auditing of cryptocurrencies is a very good question. Luckily, I prepared a slide on it. So blockchains give us a great deal of information and assurance about some elements of transactions and very little about others. So, for example, if a company comes to me and says, okay, well, we've got 100 Bitcoin as a company because we accept Bitcoin for payment, and we want to put this on our balance sheet, there are certainly some things that we can do to test what they say is true. This, if you can't see the picture, by the way, it's chocolate Bitcoin that you can buy. So how do you tell a real Bitcoin from a chocolate Bitcoin? Well, one of the things is, because Bitcoin is public, you can just go look at the register to see how much they have. And there's also a lot of places out there where it's being traded, so you can get a valuation. One of the questions that's a little trickier for something like that is ownership. If I want to confirm that a bank account really does belong to my client, I can go and send a letter to the bank to get them to confirm. But I can't do that because there is no bank. But what I can do is get them to make a dummy payment. So I can say, well, if I'm set up a Bitcoin wallet address or whatever cryptocurrency address, I would like you to send 0.0363 Bitcoin to this address. They do that. You check the amount is correct, send it back. You know then that it's theirs because they've been able to show you that they can spend it and they have the appropriate rights, and that shows you that it really is their money. More generally, in terms of blockchain gives you, as I said, assurance over some aspects but not others. So it will definitely tell you that the transaction is real, that the amount is certain, that the counterparty with the transaction agrees to the details. But it doesn't, that's not all that accounting is. We have to consider not just the debits and credits, but also the meaning and the larger business sense. So for example, if I'm running my supply chain and I have got a invoicing system, I might be able to see on the blockchain that this invoice was issued on the 31st of December for €1,000. And I know that's the case. I don't need to check with the counterparty. I can prove that using the mathematics that makes the blockchain work. But I can't know whether or not my customer is ever going to pay this invoice. I don't know if maybe they are going to go under, and whether I need to allocate a provision against this invoice. That's a judgmental aspect that involves information that's outside of the realm of what the blockchain is able to see. And so I do still have to apply judgment in those cases, and I do still have some things to do as an auditor there. But the transactional level detail stuff is much easier for me, but that gives me more time to think about the more interesting questions. It also doesn't tell me, of course, okay, maybe I made a purchase of €1,000. Again, I know that the purchase was made and the timing of it, but whether that purchase was an asset or was a cost of sales purchase or an expenses purchase is not within the scope of what's captured in that blockchain. That's still something that I have to think about and apply my judgment as an accountant to. Okay, another question I want to take from the back. Yes?
My question is about the cryptocurrencies. You said that cryptocurrencies are based on centralization. So currencies all over the world have a bank to back them up for the IMF. So how can we expect the financial sector of the industry would faith on cryptocurrencies such as Bitcoin when we know that these cryptocurrencies are vulnerable in potential manipulation or other things? And how can we may face these potential challenges that may arise in the future as we keep on using them?
Sure. So if you couldn't hear the question there, it was about the how you can have trust in a cryptocurrency and its valuation. Well, the first thing to note is that, as you will notice if you look at the history of the value of cryptocurrencies, that many people don't have faith in the usefulness and of cryptocurrencies, because it's been going up and down and changing a lot as people have been, as the kind of tide of public opinion has changed. Most currencies these days don't ultimately go back to a reserve of gold somewhere in a vault anymore. They're fiat currencies. They are worth money because the government says so, and we trust that the government is going to treat the money properly and that it's still going to be there, and so we trust that the money has value for this reason. For cryptocurrencies, the value is from the fact that they're much more like something like gold. There's a fixed amount of them, they're hard to get and hard to fake, and we think that maybe they are useful and they're hard to get, and things which are hard to get and useful are valuable. Now, the problem with cryptocurrencies as a store of value and as being able to use them to buy and sell things is that we don't have as much experience with them economically, and there isn't yet an agreed way of really knowing the true value of these currencies. They're still proving themselves relative to these other solutions, and so yes, the value is going up and down. We do also have this problem that, just like cash, the provenance of where they came from is not really known. And so I do have to worry if I am accepting some Bitcoin. I have to think, well, just like if somebody shows up to pay me a big wad of euro notes, I have a little bit of uncertainty. Where did this really come from? How did this person get these funds? And I have to have a certain amount, if I'm a proper accountant and I'm applying my professional skepticism and thinking about my duties for anti-money laundering, I have to do some due diligence of where those funds really came from. So that's certainly something we have to be concerned about. Personally speaking, I have a lot more confidence that blockchain as a business solution has a future than that any specific cryptocurrency does. I don't hold any cryptocurrencies. I think it's less certain what the usefulness of those is going forward, but nobody could be really certain. I'm conscious that we need to wrap up, so if we can take one final question, and then we'll finish. So asking the question there again, if you couldn't hear, was about which countries and industries have been most seeing the advantage. You are right, Malta has done a lot, and they obviously have the advantage that it's a very small country, so being able to put some of those things in place is a little bit simpler. Estonia has also done some interesting stuff with blockchain for tracking updates and changes to their citizens' medical records, and Estonia generally are a good model for electronic government and digital administration. In terms of industries, it's probably is the shipping industry where I've seen the most activity of these kind of projects going on. I haven't yet, as I said, seen that many business as usual applications for any blockchain thing yet, so it's still something where there is work to be done to figure this stuff out. There are companies out there that do just use blockchain on a day-to-day basis, but they are the minority, and most are still in a research and proof of concept stage at the moment. So we will see, I suppose, is the answer. All right, that's everything from me.